Okay, so we're going to be moving on to kind of stage 2 in our area journey. It's got the same front on it, all about the base and height. And so if you remember, the last video talked about where we're heading. So we're really working on the foundational skills right now. Down here in the foundational, we are decomposing and then recomposing. We are working with different shapes like rectangles. Today, specifically, we're going to take a hard look at the parallelograms, but all of that is getting us to finding the area of polygons by decomposing them into rectangles and triangles. Okay, so you kind of got a taste on that after the last video, trying to put things together. So let's kind of take a look at a parallelogram. Okay, so we have to first remember what makes a parallelogram a parallelogram. Okay, so we have to think about it's a four-sided figure with two pairs of parallel sides, and opposite sides are equal length. This is a lot of words here we've got to think about. Parallel means the lines can go on forever and never touch. Never touch or intersect. That's kind of the fancy words for touch in math. Okay. Two pairs, and then opposite means across from each other, and equal in length, so that means they're the same size. So let's draw this parallelogram. I always think of it looking kind of slanty. Okay, so what this is saying is two pairs. Here's a pair, they're parallel. That's one pair. Here's a pair, they're parallel. Okay, the green is also the same size as the blue. Okay, that's what it means when it says opposite sides are equal length. So this is what makes a parallelogram a parallelogram. A rectangle is a special type of parallelogram. Well, think about it. A rectangle follows those rules. This is the same size as this. It's parallel. They'd never touch if we continued. This is the same length as this. They're also parallel. They would continue forever and never touch. The only thing that's different or special that makes it a special parallelogram is the angle. And we haven't really worked a ton with angles yet, but in sixth grade, you're going to start to. Every angle on the rectangle is a 90 degree or a right angle. That's what makes it a parallelogram, but it's a special parallelogram. Okay, this is why geometry is kind of tricky, because it's a lot of rules and different vocabulary stuff you have to remember. So there is actually a way to turn a parallelogram into a rectangle, and I'm going to show you what that is now, because we already know how to find the area of a rectangle. You would just take the base times the height, or the length times the width. So you would multiply the side lengths. And we can do the same thing with a parallelogram. We just have to know a couple of things. The parallelogram, if I were to cut this, it makes a triangle. Okay, so we see this triangle right here that I've made by cutting. Okay, what that also does is it makes this a right angle. So I'm starting to turn it into that special parallelogram, also known as a rectangle. What's interesting is if I take this yellow piece, now that I've cut it off, and I move it over here, it actually fills in this kind of blank spot over here. It also forms 90-degree angles over here. So then what we see is after we've cut it off and moved it, we have actually created the rectangle that I'm highlighting in blue. Now, what you need to understand is where the measurements are. So we have the length and the width. Well, the length stays the same because we've just taken this piece, we've moved it over here. So either way, that would be this measurement. Okay. But what we need to understand is the height is slightly different, or the width. It has to be this straight up and down. It would not be the actual side length of the original parallelogram. Okay. We're going to call that now the height. It's the actual how tall it is. Okay. It's not the length of the side. It's slanty. It's going to be longer. Okay. We want to look at it from the height or the distance from the top to the bottom. We want to know the distance between the top and the bottom of the shape. Okay. We also call this the altitude. The altitude of the parallelogram is the perpendicular distance from the base to the opposite side. We consider this the base. You already know what perpendicular means, you just don't know it. Perpendicular makes that right angle. Okay, that's all it is. Okay. So that's where the measurement has to come from. So when you're taking a look at examples of parallelograms to find the area of, if they give you this measurement or this measurement, you're going to ignore it. Okay, they're trying to trick you. Now, you would need that if you were finding the perimeter or the distance around. Okay, but for area, we do not care. What we're interested in is the altitude or the height. Okay, because remember, if I cut this off and move it over here, then this 5 yards is actually the side length to my rectangle that I have formed. Okay, if I move this triangle over here, then this 4 feet is the side length of my new rectangle. So the area is going to be the base, which is what it's sitting on, times the height or the altitude. Okay, it's 6 times 4. That's 24 feet squared. Remember, area is always squared. The area of this, same thing, base times height. It's literally length times width, like you were doing with the rectangles and the squares. We're just calling it base and height because we have a different shape. So we're moving towards some language that's going to help us with triangles. We have the base, what it sits on. Okay, we have the height, which is perpendicular to the opposite side. See, and this one is in yards squared. Okay, let's take a look at 2 more parallelograms. Remember, I'm not interested in this length. I'm looking at the 2. Do you guys see that? 2 and 10. So 10 is the base, 2 is the height. So the area equals the base times the height, which is going to be 10 times 2, which is 20 feet squared. Okay, now this next one, it looks kind of weird, okay, but you can still see this right here tells us that that's 90 degrees, which makes it perpendicular. Let's see if I can spell that right. Okay, that little box. Okay, so we know that we want to use the number 8 for the height and 6 for the base. That's the height. This is the base. So the area equals base times height. Once again, I'm writing that every single time to get my brain used to it. That's 48 yards squared. Okay, so that ends it for parallelograms. We're going to do some practice with that, and I wish you the best of luck. Practice hard because we're going to be putting all of this together soon. Okay, thanks.